Hi everybody, today we are going to learn a new word called the discriminant, okay? And this word, the discriminant, is going to help us determine the number and what we call the nature of the actual solutions. So remember this word solutions. You could use a lot of other words to explain solutions. Hopefully you remember roots are the same as solutions, zeros are the same as solutions, and x-intercepts are the same as solutions. So in this first example, they're asking us to solve using the quad formula. Okay, so we see that it's in standard form, so I can immediately identify A is 3, B is -4, and C is 10. So I'm going to write my formula down that x equals -b plus or minus our square root of b squared minus 4ac, and that whole thing is over 2 times a. So once I'm there, I am going to plug my values in. If I have to negate b, and b is -4, that's going to wind up turning into a positive 4, plus or minus our radical -4 squared minus 4 times 3 times 10, all under the radical, and that's over 2 times a, which is 3. Okay, so I'm going to bring it up to the top, and I'm going to simplify into my 3 pieces. My positive 4, negative times a negative gives us a positive, my radical over 6. So I'm going to pull up GeoGebra to help us see our number that we're going to get under the radical. So under the radical, notice I don't hit the radical button. I'm going to highlight what I'm typing in right here. Okay, I'm going to type in -4 squared minus 4 times 3 times 10. And look at that number. That number is -104. -104. So I'm going to highlight it. This number, the number under the radical, is that word I was talking about before. This is called the discriminant. And this discriminant, the number under the radical, is literally going to tell us the number and the nature of our solutions. So what's so weird about that number that we have yet to see? It's negative, okay? We have never seen a negative number under the radical. So I want to show you something. If I typed in this equation, okay, so I'm going to come back here, and I'm going to type the equation 3x squared minus 4x and plus 10. Okay, I'm going to see a parabola. And I'm going to bring it here. It's like make it a little bit bigger, right? So where are your solutions or your roots or your zeros? They're where the graph crosses the x-axis. Now, it's a little bit hard to see, but can everybody see the x-axis? Okay. Does this graph ever touch the x-axis? No. So this picture right here, right? If I were going to sketch what this graph looked like, your parabola was up here. So you know what that tells us? I'm going to put it in a new color. There are no real solutions. It's not even like they're irrational, crazy long decimals. There are no solutions. The graph doesn't cross the x-axis. I'm going to say graph doesn't cross x-axis. Okay, so the equation above has no real solutions. Okay, no real solutions. So again, just by knowing this number, this -104, is going to tell us something about our roots. As soon as I see it's negative, I'm going to know. So look down here, notice here. When I see it's negative, it immediately tells me there's no real solutions. Okay, so what are your other options? If it's 0, there's only going to be one real solution. And if it's positive, there's going to be two real solutions. So if you notice, this is what we've been doing, okay? This is most of the time, okay? Because think about it. When you guys have been solving using quad formula, every number under the radical has been a positive number. It could have been any number, like 1 through, it was, I don't know, up to, let's just say 200 and something, but it was a positive number. You have yet to see 0 or a negative. So there's your first experience with a negative under the radical. It means that your graph does not cross your x-axis. Okay, so let's try another one. Here's the good news. You don't have to use the quad formula just to, look what I'm asking, determine the number of real solutions. So what's going to tell me the number of real solutions? The discriminant. And what is the discriminant? It's b squared minus 4ac. Where did I get b squared minus 4ac? Think about your quadratic formula. It's this right here. It's your number under the radical. This is your discriminant, okay? So all you have to do for, let's just say, example number 2, is figure out b squared minus 4ac. Whatever number is under the radical, that's going to tell you the number of real solutions. Now here's the problem with number 2. People are going to say, oh, a is 2, b is negative 4, and c is 3. That's incorrect. This is not in standard form. Make sure you move your 3 over, and it becomes, I'm going to move this one down, 2x squared minus 4x minus 3 equals 0. So now you could tell me a equals 2, b equals negative 4, and c equals negative 3. Okay, so b is negative 4. So look, I'm going to plug in negative 4. I don't know what that's about. Square it. Minus 4 times a is 2. And c is negative 3. So I'm going to go to my calculator, pull up GeoGebra, I'm going to clear out what I had, and now I'm going to do a parenthesis, negative 4, square it, minus 4 times 2 times negative 3. Okay, and that's going to give me my discriminant. My discriminant is the number 40. That means, think about what that means. It means it's a positive number. That means right here, positive, 2 real solutions. So 40 means you're going to have 2 real solutions. That means your graph should cross your x-axis twice. So I am going to prove that to you. If I type in 2x squared minus 4x, now I could either do minus 3 or I could do equals 3. I'm going to do just minus 3 once it's in standard form. And now look, here, right here, even though it's irrational, it's a real solution. Even though it's irrational, it's a real solution. It hits at 2.5811. This one hits at negative 0.58. Irrational, okay, so I'm going to make a little note that they are irrational, but it doesn't matter. They are real. Real means any number you could ever dream of is a real number, okay? So there you go, and that's how you're going to check it. It's not like it was a negative. If that was a negative, then this graph would never even hit the x-axis. Okay, so let me try one more over here with you. Let's do purple. Okay, so in the second example, we're going to state A, B, and C. It's in standard form. So A is 1, B is 2, and my C is 1, okay? So again, I only have to do b squared minus 4ac. That's the discriminant. That's going to give me all the information I need. b is 2. 2 squared minus 4 times a is 1, and c is 1. So that's where I'm going with my calculator. I'm going to scroll this over just a little. I'm going to clear out what I had. And I am going to type 2, make sure it's in parentheses, squared, minus 4 times 1, which obviously does nothing. And look what my number is. That 0 is my discriminant. Okay, so what does the 0 mean? It means that I'm going to have one real solution. Okay, and now I'm going to prove it to you. If I take that equation and type in x squared plus 2x plus 1. Okay, look at that graph. How many times does that graph hit the x-axis? One and only one time. Okay, it's what we call tangent to the x-axis. It skims it, hits it once, and goes back. It does not fully go through 2 times like you saw in the last example. And this one happens to have a really nice root. It's just a integer -1. Okay, so you have an integer value at -1. I'm going to call this, it's an integer. Okay? Okay, we're going to try 2 more. So let's take a look at number 3. In number 3, you see what is the solution to this quadratic equation, and they want to know, are they rational or irrational? Okay, so here's the good news. Technically, if they want to know if they're rational or irrational, justify your answer, well, guess what? You guys can go right into your calculator. Okay, and look at the solutions. If I delete this and I type my 2x squared plus 3x minus 10, okay, there is my parabola. And I touch on that root. Okay, so there's one root. I'll write it down. Looks like something like, I'm going to go back to my pink. X equals -3.108, -3.108, blah, blah, blah. And you have another one, x equals 1.608, 1.6084, something like that, okay? So tell me, are those numbers rational or irrational? Clearly, hopefully, you know they're what we call irrational, okay? So I'm going to just make a note. Sometimes it does that, sorry. Go back into here. Okay, and I am going to say your solutions are irrational. Okay, we looked where graph hits x-axis. Okay? Now, what's the other way you could prove it? You could do, well, actually, I think that's the better way. I was going to say you could do the discriminant b squared minus 4ac, but to be honest with you, if b is 3, a is 2, and c is -10, you get a discriminant of 89. 89 not only tells you have 2 real solutions, it means they are irrational because it's not a perfect square. So I think the better way is to just put it into the calculator and look at your solutions where they hit the x-axis, okay? So these definitely happen to be irrational. Okay, so we can determine the number of real solutions based on the graph. The number of real solutions is the same as the number of times it hits the x-axis. So graph the following using your calculator and determine the number of real solutions. So that's all I want. I don't care the explanation. I'll give you more info, but let's just pull this up and let's see about how many real solutions. So in the first one, I have 4x squared minus 5x plus 10. Okay? So very clearly, how many real solutions do we see? 0. Okay? I would say there are no real solutions. Okay? Or 0. There are no real solutions. What does that mean? Well, come back up here. What did no real solutions mean? It means your discriminant had to be negative. It means your discriminant must be negative. Okay? And I could prove it to you if I did b squared minus 4ac, and b is negative 5 squared minus 4 times 4 times 10. So watch this. If I do negative 5 and I square it, minus 4 times 4 times 10, there's my negative 135. So there's my proof. Okay, let's try the next one. Okay, the easy way to do it, just to find the number, it's only asking you for technically the number of solutions. I'm going to type in x squared plus 5x plus 6. Okay, and I'm going to look at the graph. How many times does this graph hit the x-axis? Clearly, twice. So I would say there are 2 real solutions. Now I want you to take note of the solutions. Negative 3 and negative 2. So negative 3 and negative 2 are your solutions. And they are integers, which means your discriminant had to have been positive, but it had to have been something else. It should be a perfect square. So if I do b squared minus 4ac here, and I do 5 squared minus 4 times 1 times 6, so let's do that. 5 squared minus 4 times 1 times 6, look what I get. The number 1. That gives me a perfect square, which means my numbers are integers. I'm not getting crazy irrational roots like we did before. Okay, I'm going to do this last one with you. I'm going to clear this out, and we're going to type x squared plus 12x plus 36. Okay, and there it is. So clearly, how many solutions does everybody see? 1. This is only hitting in one spot. There is only one real solution. And that solution is negative 6. Everybody see that? Okay? So that solution of negative 6, that means if there's only one of them, it only hits in one spot, it meant your discriminant must be 0. So I'll prove. I'm going to get rid of this so it's a little bit smaller. So if my discriminant is 0, if I do b squared minus 4ac, and my b is 12 squared minus 4 times 1 times 36, 4 times 36, it's 144 minus 144, it's 0. And that 0 is going to tell me I have one solution. So you just learned a lot of info. Let it soak in. Okay, again, to find your number of solutions, you could literally just put it in the calculator and check to see how many times it hits the x-axis. And your discriminant also helps you figure that out. If it's positive, there's 2 real solutions. If your discriminant under the radical b squared minus 4ac is 0, there's no real solutions. If it's, one real solution. And if it's negative, there are no real solutions. Okay, I'm going to give you guys a practice sheet.